2008 Saturn. What is this thing? Saturn what? It's a Saturn car. It's a Aura, or A-U-R-A. Right, Evan? So Evan's going to hit OK. We're doing a full system scan here. Sorry about the glare. He's going to hit fault scan using the topology. We got this car because apparently when you're driving it, I haven't seen it yet, but the instrument cluster will basically, the gauges will all go down, not reading correctly. All the lights will come on, the gauges will come on. It'll still run fine, then they'll shut it off, and then they'll try to start it. They'll try to start it, and nothing will happen. It won't even crank or nothing for 5 minutes, sometimes 10 minutes, sometimes 50 minutes. And they'll let it reset or sit there and it'll start again. I guess the ignition switch has already been put in this car. So what we're going to look at here is, here's our high-speed can or blue wires. Our blue tracers are high-speed can for ECM, TCM, EBCM, which is your brake module, body control module. And then your low-speed can is your airbag, instrument cluster, radio, and all kinds of other stuff. So let's go into the report. First time looking at this. So the engine control module has a P0128. Engine coolant temperature below regulating. Engine coolant temp below thermostat regulating temp. Current DTC means it's probably a thermostat that's partially stuck open. Well, actually, maybe not, because I did notice this car when I drove it in here that the fan was on high speed and the temperature was all the way cool. So that's why I couldn't do that. So it may not be a temperature thing as far as the thermostat. It could be that it's in regards to that fan was stuck on. Well, why is the fan stuck on? Typically, that's a sign that there is a communication issue. TCM requested mil P0700, which means we need to look into the TCM code. Transmission torque request circuit from the TCM will look. They're current there. Control module communication bus off. Current. That's the ECM. Control module communication bus off. We need to look at that. Transmission. So the P0700 tells us to go to the transmission now. We were in the engine. Control module communication bus A off. Same code, 0073, U code current. EBCM, which is on the high-speed can, just like the PCM and the TCM is. But the EBCM is U2105, lost communication with ECM. Current, lost communication with BCM. Current, even though it says this, ignition pass, so we got to look at this. Lost communication with TCM. So the EBCM lost comm with the ECM, BCM, and TCM. And the body control module, which is on the high-speed can, lost comm with the ECM, lost comm with the TCM, and lost comm with the ABS. And the radios on the radio is on the low-speed can, or medium-speed can, which is a circuit low voltage, don't care. So, if you look, this low-speed can here, no, I'm trying to click on it, but it ain't working. But this, oh, anyways, that's the low-speed can. I'm not worried about this. This is reading correctly. The high-speed can, the blue here, is not reading correctly. We have all kinds of communication between these modules, which on this is the 08. It should be a can high, can low, pin 6 and 14, or GM LAN maybe, General Motorized Local Area Network, which is GM's shot at being a CAN compliant vehicle. So we'll get the schematics pulled up, printed off, and we'll go from there and look. And I'm wondering, I think that coolant temp sensor has, or P0128 has to do with the fan being on, because there's no comm. If there's no comm to the ECM, it'll turn the fan on high, which will throw that other code, and that's a communication code. As far as the instrument cluster doing its light thing, it's getting data from the engine, the transmission, the EBCM, all that stuff. And then the no crank, no start when it does it. You know, the crank signal probably comes from the ECM. So we do got comm issues. The thing I'm going to do next is look at the wire schematics and look at the CAN bus and go from there. All right, so I got the schematics printed off here. So our high-speed can are these two, and our low-speed can is this one. So low speed's your instrument cluster and radio, and don't care about that one right now. Our high speed we care about, but I need to find out the RPO code, regular production option. Is it an HP7 or is it without an HP7? So we're going to go over to the glove box on this guy here and look. Well, I'm going to grab a light. All right, see if it's got an HP7 in here. It's an alphabetical HP0. Let me show you here. You can see the HP0 in the center of the screen. So it's without. It is without HP7, right, buddy? Turn this light off. So it's without HP7. So it is this one right here. For a high-speed can without HP7. So let's look. Here's your DLC. Pin 4 and 5 are your ground, like in any DLC. Pin 16 is your power. 6 and 14 is your can high, can low. One termination resistor goes to your BCM 120 ohm resistor. Shielded. And we got to see if it's got a UE1 or not a UE1. But it goes for your VCIM module, to your power steering control module, if it's got the NV7 or not, to your EBCM, and it shows you the pins for your other RPO codes. We're going to have to highlight this out. Then your TCM and your ECM. So your ECM has the other 120 ohm resistor, 120 in parallel to 120 in parallel. You get 60 ohms across the bus for pin 6 and 14. So we want to check that as well. But before we do that, we can go in the measurement tab here, go to bus inspection, because we still got our VCMI plugged in. And if you look, go to view waveform. There's pin 6. Let me put a trigger on here. Let me turn the trigger off. And let me go like this. Slow this thing down. There's can high, which if you freeze it here, your 2.5 bias voltage should be in the center, going to 3.5 roughly. Here's your zeros and ones. It is kind of, I mean, I normally see these little flags on the end of these, and that's pretty normal, but this ramp up is a little different than I'm normally used to seeing. I'm not saying that is or should not be there, but it is a little different. Let's go to can low now. Same thing. From 2.5 to 1.5. Well, it's kind of ramped up there. And if you look, well, let me see here. 2.5 to 1.5, but then this one goes from 2.5 to 2. 2.5 to 2. That's not right. That would cause bus issues and communication issues, I believe. So yeah, I think there is. That's showing us we have a bus issue. Let's check the continuity across pins 6 and 14 next with a breakout box, and then we'll start scoping it some more and see what we can come up with. Well, before I go any farther, I looked in the RPO code. So this is the UE1. So it goes through, we have the VCIM. We don't have, it's the NV, it's not the NV7, so it's the minus NV7. So it goes around the power steering control module. And it goes up through the EBCM. Let's get LZ4 for this connector. X108 pin S. Same thing up here. This connector. We have the MN5. And go through up here. And we have the LY7. So, just to show you that again. If you go back to this. Diagnostics here. Come on. If you do a fault scan, load scan again, and I'll show you that we do not have a power steering control module on the high-speed bus. Again, on the high-speed bus, that's going to be gray, no response. It's going to scan it, but it's going to have nothing. So we have the ECM, boom, TCM, TCM, boom, EBCM, boom. So we got those three. BCM, well, boom, BCM, boom, and we're going through the VCIM. Well, they're showing on here the VCIM on the Autel showing on the low speed cam, but it's showing it goes through this right here. Or does it go around it? Shows it goes through it. Anyways, I don't care about that part. And then the power steering control module, which is this one, we don't have, obviously because of the RPO code. So now let's, again, check the resistance. Pin 6 and 14 for the CAN bus. This is a CAN bus system. Let's check that. We should have 60 ohms across the bus, plus or minus a few ohms. Then we'll go from there. All right, so now we're going to read the resistance across the bus. So Evan hit that. Evan's helping, right, dog? And we're going to change this to a digital mode. I'm going to go to resistance. Amplitude, we'll go max. Let's calibrate our leads. So, using the VCMI, got the leads plugged in. To calibrate, I'm going to put them together. Put them together. All that does is, over here, buddy, hit confirm. It just takes the and zeroes them all, basically. This glare, I need to start using a screen recorder. All right, so we're gonna hit play now. We should have OL. Let's plug it in to 6 and 14, and I got my breakout box hooked up. Six, 14. Why in the heck do we not have any reading there? Let me look. Am I missing something? Let's turn the key off, make sure. I got something weird going on. So I plug my leads back in, and I got, 0 ohms, right? When I unplug them and plug them into pin 6 and 14, when I'm in 6 and 14, all right, now we're good. 65 ohms. For a second there I had 0. It must have been a bad connection on my side. So that's good. 220 ohms in parallel, or 60 ohms. All right, so I got it plugged in. Here's what's weird though. So we got our 60 ohms roughly, but then I reverse these leads, which shouldn't even matter. You're just checking resistance, right? And then I get 0 ohms. Makes no sense. So we're gonna get rid of that breakout box. I'm gonna go right to the DLC and check it that way. I figured out. So I flipped it back and forth, still read 60, 63, 65 ohms. Verify with some DMM as well. I had this thing on a really big scale. It obviously goes to that because of the decimal point. So I went down to, you can go to auto. 63 ohms. Just leave it on auto. If I go back and flip it, so I flipped it, 60, 65 ohms. So that's good. It's just my scaling on there. And we're checking across pins 6 and 14. So, we got 60 ohms across the bus, which is good. If we had 120 across the bus, we'd have one of these termination resistors that's bad, but it's obviously not the case. So now we need to go, I don't know, it just seems like that waveform's not correct. So we need to maybe, hook up the oscilloscope and read it and go from there. Now we're going to use the oscilloscope on the VCMI here, kind of like we did with the breakout, the OVD one, but now we're going to do just right with the oscilloscope. Evan's going to hit oscilloscope. And then once it pulls up, I'm going to stop this. We're going to hit 5 volts DC. We'll put a trigger on and we'll hook up our leads through our breakout box. We can do 2 at a time, can high, can low, but we'll use one for ground, pin 4. You can go to pin 5. Let's go to pin 6. I gotta turn the key on so we actually have some bus activity. That's can high. Yeah, let's see here. Same thing, it's got that swirl going up. That's can high, pin 6. Let's go to can low. Now we could use 2 channels, obviously. Piggyback the grounds if we wanted to. There's can low. And just use it to slow it down. Still got that arch going up. I don't know if that's an issue or those messages there. What we could do is unplug one module at a time and see if that waveform cleans up, or maybe it's supposed to look like that. So I started it, and if you listen, the fan's on high speed. I don't know if you hear it over the engine, but the fan's on. It's a cold engine though. Temperature is on the bottom right down there. So we're getting a P0128. If you look, still got those arches going up, a little bit of interference there with the hash there. Kind of expected. Same thing I see on my Tahoe. There's your can low. Let's go to can high. There's your can high. We definitely have a cooling fan going on, so more to come. What I'm going to do real quick is I'm going to erase all these codes since I got them written down. See what comes back. But it may take a minute, or it may take a few minutes to come back. Who knows? So rescan it after we erase them all. It's all green now. Let's false scan it again. We'll start it and rescan it again and see if there's any issues. And then we'll see if it comes back, or if it doesn't, we can check the waveform again. And the only thing we can really do after that is unplug these modules one at a time. See if anything changes on the bus, but the bus doesn't look that bad, honestly. But we can still check it for those little spikes in the bias voltage. The bias voltage means don't do anything. Alright, I rescanned it. I'm rescanning it. It's running. And you can listen, the fan's not on now. The cooling fan is not on now. I cleared all the codes. Engine's still cold. No codes right now as it's scanning. Cooling temp is still low, but it's not turning the fan on because we have COM with everything. There's no U codes that are active in there. And that's why those codes are active. That's why the electric fan is on, because the codes are active for U codes, so it defaults and turns the electric fan on. So it's obviously not a relay issue with that. Now you probably want to have a P0128 once it does its warm-up cycle, because that's good. But we need to figure out why these U codes are coming back. I think the customer said it's worse when it's cold, which would make sense if we have a bus issue, pin retention or something. So more to come on that. Already with it running, go to can high. Still got that spike going up, but it may be supposed to be like that, but all the wave zeros and ones are pretty much even. Go to can low. You can see, like when they stop it here, oh, that's much longer message than that one going down. Like that's going from 2.5 to 1.5 or 1.25. That's going from 2.5 to 2, which we had before. So we can unplug these modules one at a time and see what we have on the bus. Alrighty, I turned the car back off, key on, engine off, VCMI still hooked up, and I was scanning, or looking at can low, right? 2.5 bias voltage going to 1.5, key on, engine off. Well, look, I got a big spike right there. And I'm like, well, that's not right. That's completely wrong. That mess, and even these are wrong. This should be from 2.5 to 1.25, 1.5. That one goes way up. So that's very interesting. So it looks good there, besides the point of this arc going up, and this looks good going down from 2.5 to 1.5, 1.25, but this is not going down here correctly. And look at the, you rescale this. About 5 volts there. So 2.5. Let's just get this so we can get our center line at 2.5. There's 2.5 volts for the center line right there. Bias voltage. Like I said, bias voltage is good there, but then it spikes up. These long messages are good, and then these don't even go down to where they're supposed to be down to here, 1.5, 1.25. But that's only on can low. And then once in a while, we'll see it spike up. So take this trigger off. Slow this thing way down. I don't see it now, but I see once in a while it'll spike up. So I think the way for us to find that is we're going to have to wiggle harnesses while we scope it, and or take a modules off the bus and see if the bus gets better. See which one's causing this issue. And it could be that when it's cold, it is worse because of pin retention, like I said. Let me just look at this some more. I got it on film. What in the hell is that? I'm on a 10 millisecond division. 2.5 volts. There's your bus problem. 2.5 volts bus. We're on can low right now. We're on can low, and this should be going down, which it is here, but then it's way up there. There's a... That does not look right at all. That is completely wrong. Go back to can high. That's completely wrong too. There's the bus issue. That does not look right. Unless I'm seeing it wrong with my eyes. No, that bus is all jacked up. Put a can low. That's completely wrong. So let's back out of this. See if you got any COM codes now. It may take a while. So I'm going in here, going to rescan it real quick. I'm not saying we're going to have any COM codes, but you could see right there on film that that bus was completely messed up. No COM to the ECM, no COM to the TCM, no COM to the EBCM. There it is. COM to the SIR. No 3 codes in the VCM. We're on to something. Finally. We just got to find what? Trying to talk through this. So high-speed bus to low-speed bus. Low-speed bus, we're probably going to be good because that's a different bus. Right, Evan? That beeping you hear in the background's Evan because he's got diabetes. So we got to watch his sugars all the time, right? He's got type 1 diabetes. So low-speed bus, good to go. High-speed bus, no COM to ECM, TCM, EBCM. Don't care about the power steering control module. It doesn't have it. 3 codes in the BCM. Let's see what they are. And if you look, yes, the body BCM lost COM with the ECM, lost COM with the TCM, lost COM with the ABS. Current. And it is current. So let's go back out of this. This is what's nice about this thing is we can go back and forth. Actually, I could split screen it with my oscilloscope instead of using the bus inspection. But we definitely have a bus issue. So let's look at the waveform. There it is. It's messed up again. 100%. Steve, what are you doing? Sorry about my, he's a little clumsy maybe. So let's go in here. Let's turn the trigger on. Yeah, that bus is, this is can high right now. Completely messed up. Can low. Completely messed up. Holy crap. So now, buddy, can you come here? What I want you to do is see this wire right here? This wire? I want you to wiggle it when I tell you. Just wait. Go ahead and wiggle it. That bus is messed up bigger than crap. All right, hang on a sec, buddy. All right, since I got my assistant here, Steve, smile. Yeah, very good, dude. Right, buddy? Okay. So we're on can low. Completely screwed up bus, right? We know that, whether it's can high or can low, and we showed the codes. Right, it's messed up. So I have my buddy Steve here. He's going to go up to this. This is the EBCM, the harness for it. When I tell him to wiggle this top wire, he's going to wiggle it, but not yet. Okay, go ahead and wiggle it. I just want to see if anything changes on the bus while he's doing that. I'm not saying it will or won't. You're wiggling it pretty good, Steve? Yeah. Nothing. Nothing there. Okay. Can you see these two wires, these harnesses on the computer? Wiggle this first one right here. Go ahead. I just want to see if this bus comes back from doing any wiggling on harnesses. Nothing? Okay, go to the next one. Get your hand. He's got big hands. Feel bad for his wife. Go ahead. Same thing. So what we're doing, you can stop. What we're looking at here, we're wiggling on the ECM. We didn't do the TCM yet. I believe that was the ECM. We'll have to verify that. We did the EBCM. We don't have the power steering one. The VCMI we can look at. The BCM we got to look at. So what we're going to do now is my assistant is going to... Can you film this? Just hold that. I'm going to try to take the EBCM offline and see if this thing fixes it. That way, if I pull the EBCM connector and this gets better, then we know it's EBCM. I'm not saying it is or isn't, but oh man, this stupid cover. Good, buddy? All right, let's pull this back. Watch that scope. Definitely lose calm now. Looks a lot better. Like significantly better. Take the trigger off. We still have these spikes going way up, but we had those before. But if you look now, let's slow this. There's a lot less activity on the bus now. But that looks completely weird to me. We have the long spikes like before we had the short ones. That's going down to 1 volt. Let's go to can high. Same thing. Back to can low. Let's plug it back in. While you watch the scope, I'll plug it back in, clean all the dirt off. They come back. It's all jacked up again. Okay, I have it plugged back in. Let me unplug the EBCM. And it gets better. But it's not right. But if you look at the schematic here, to go through the EBCM, it goes through the EBCM to the TCM to the ECM. So we're taking this out of circuits. We don't have a bunch of data on there because we eliminated these other ones. So go back to that. Put it back in again. See what happens. Same crappy wave. Still messed up. So leave it. I'm gonna unplug the ECM now. Just keep watching it. It's easier said than done. Okay. Well, I unplugged one of the computers here. What is going on? I just unplugged one of the computers. Looks a lot better there. But that's the engine computer now. So let me plug it. So unplug. Then there's your long and your shorts again. Long, short, long, short. Plugging it back in. And it's all back to normal. For what it was earlier. Yep, it's all back to normal now. So the bus communication is restored. I literally unplugged the EBCM, did some weird stuff, it went away, and then it came back after I plugged it in. I did the same thing with the PCM on one of the connectors. So if we go back to this now, I bet you we got calm again. So we go back to this, go back to this, go over here, and then we're gonna have a bunch of codes, history codes or current codes or whatever, but we should have calm again. Green, calm. Calm, but we have codes, calm. Maybe there's a T-cement plug, I have to see here. We have calm, but earlier we didn't. So I don't care about this bottom. I'm going to pause it. I just care about the high-speed can. I'm going to go skip the mileage. This glare is so bad. So the TCM lost calm with bus A off. Well, yeah, because the bus is off because it ain't doing it. That's what it's considered. Lost calm with the ECM. Lost calm with the EBCM. Lost calm with the BCM. Lost calm with the ECM. So that was the ECM. So let's clear all these. And what we'll do is we're going to scope it one more time. And we're going to have to look into this more and see what we're changing. I thought when I did the EBCM it changed, which it did. That was the issue. And then I did the ECM, and then it changed as well. But one of these modules is causing an issue. Whether it's the ECM, the EBCM, we look, maybe the TCM or the BCM. But like I said, we do have 120 ohms across the bus. One more check here, and then we're gonna have to pause it and do some more research and see where we're going. But at least we caught it on camera. And that's, yeah, so let's look here. Yeah, let's put a trigger on. Oh, now look at that thing. It's perfect. Now if you look at that, there is no arc going up like it was earlier when I can't even talk. When I first started filming this, there was an arc going up on can high, can low, even before it acted up. This thing is perfect now. Let's go to can low. Same thing. We still have these can lows, long and shorts there, but it's not arcing up on the bias voltage. So let me wiggle it one more time while you watch that. You hear me change on middle speed. Nothing. If you hear it, you see it change right now. Mm-hmm. What I did earlier, literally, and it started acting up. It is perfect right now. Let me do some more checking here. Hang on. Nothing?
Nothing.
Do this one. Nothing?
Nothing.
Let me recycle power. Check.
Oh.
Nothing?
No,
it's gonna have that fuzz in there.
Okay.
Tell it, it does always on Chevys. Tell it. Okay, there we go. Keep anything again. Nothing?
Nothing.
I'm gonna pull this mod. I'm gonna pull the EBCM module offline.
Okay.
Probably less data talking. Yep. Definitely less data talking, but still no arcs like we had earlier with the EBCM unplugged. We plug the EBCM back in. EBCM's plugged back in. A lot more data. Just weird that those long and short ones are there. You plug the engine one again. You gotta be careful doing this with the key on and all that. Changes a little bit because of the, you know, offline, but it looks decent. A lot more data coming on fuzz. That'll go away right now. All right, so what we're gonna do, we obviously caught it on film there. The bus was messed up. It's good now. We messed with the EBCM, thought it was there. We messed with this module with ECM, thought it was there. And literally, we wiggled the crap out of these wires and nothing came from it. So we're going to have it act up again. Maybe it's a temperature-related thing, but more to come. So yeah, like I said, it's good now. And I think, obviously, what's happening in, we got to find it, but we got a pin retention or wiring thing that's causing this bus communication to do corrupt stuff. Whether it's in the EBCM or the ECM or another module or in the harness, we got to find it, right? I think it's temperature related. It is getting warmer in here with the heater on, the wood burning stove, and it's, you know, symptoms are going away. But I think what's happening, why is the fan on all the time in the P0128 is because when you lose comm, that's a default thing, especially on Chevys. I see it. Why is this instrument cluster going off? I don't see it now. Why is the gauges going crazy? Because of the, well, the bus communication. Again, it's RPM signals and stuff from the PCM and the TCM. And then when it shuts it off and restarts it and no crank, no start, why? We can look it up, but I imagine the ECM controls the starting circuit. That's why I just ignition switch is put in it, but there's still something else going on with it, obviously. I think the ECM controls that. We need to look it up. We're going to have to do some more research. We need it to act up again, whether we need to make it cold, let it sit outside for a while, because it is like in a 20 degrees. It's like 20 degrees outside, so more to come.